Now let's return to this idea of rigid motion. If you remember, when we translated a figure, it didn't change its angles, its lengths, or anything about its shape. That's what made it a rigid motion. The same is true for reflection. When we reflect a figure, it's not going to change shape or anything about its measurements. All right, so just like with translation, we had the translation postulate that said a translation is rigid motion, so a reflection is also rigid motion. Okay. Meaning it's not going to change its lengths or angle measures, it's going to stay the same shape and everything. Another term we'll want to note is about a glide reflection. A glide reflection is a transformation involving a translation followed by a reflection, in which every point P, okay, every point P, like in this this image here, every point P is mapped to point P prime by doing first a translation, so from P to P prime, and then a reflection in the line of reflection parallel to the direction of the translation maps P to P prime. Okay? So it goes from P translated to P prime and then reflected into P double prime. So it's just like a composition of transformations like we've talked about in the previous section. All right, so let's look at an example of that, a glide reflection. So in 7, we're graphing triangle ABC with the vertices A32, B63, and C71. And its image, and we want to graph that original triangle and its image after the glide reflection. Okay? So let's first go ahead and graph our image, or pre-image. A is at 3,2, B is at 6,3, and C is at 7,1. Here's A, B, and C. And so we're going to do a glide reflection on it by translating it right here and then reflecting it in the x-axis. Okay, so we're going to do both of those transformations on it. We could do this one step at a time, where we translate the figure if we want to, and then we reflect it in the x-axis. If you would prefer to do the bunny hops and count and everything, you can do that. But I think it might be simpler to look at the points and look at how we're translating and reflecting those. Okay? And I think that's good practice to know how to do that. So let's take each of our points. A is at 3,2. B is at 6,3, and C is at 7,1. And we're going to first translate all of them, and we can see our translation rule right here that's moving all of the points 12 to the left, and it's not moving them up or down at all. So all of the x values should be moved 12 to the left, and then there's nothing happening to the y values. So what that means is that when we translate, we can subtract 12 from each of the x values. Okay, subtract 12 from each of the x values. That's what this rule is telling us to do. So 3 minus 12 is negative 9. And then we don't do anything to the y values. We just leave the y as is. So 2. Same thing here. 6 minus 12 is negative 6. Don't do anything to the y value. 7 minus 12 is negative 5. Don't do anything to the y value. Okay? So those are the translated points. Okay? If we graph those onto our graph, we would see the figure move off to the left about 12 units. So now we're going to reflect it. We're going to reflect from this translation. Okay, so we're reflecting from these points here. Like I said, I didn't name these. This is A prime, B prime, and C prime. So A double prime would be a reflection of A prime in the x-axis. And remember our rule for our coordinate rules for reflections. When we reflect in the x-axis, we just change the sign of the y value. Change the sign of the y value. So the x value stays the same, negative 9, and the y value will change signs. So from 2 to negative 2. So B double prime would be negative 6, negative 3. And we're going to keep the x value the same when reflecting in the x-axis, and you switch the sign of the y value. C double prime would be -5, -1. And so these would be the points of my reflection from the translation, which is the glide reflection. Okay? So I'm going to graph these onto a coordinate plane. So -9, -2, need to get rid of that real quick. -9, -2, that's A double prime. -6, -3, that's B double prime. And -5, -1, that's C double prime. And so there is the glide reflection of that triangle. Okay? So again, you could have bunny hopped over with the with the translation and then looked at the reflection to see where the points were. But it might have been easier, and it's definitely good practice to figure out how to do that with the coordinates. To do this right here, I take my original coordinates, translate them using my translation rules, and then reflect them using my reflection rules. Lastly, today we'll look at the idea of a line of symmetry. A figure in the plane has a line of symmetry when that figure can be mapped onto itself by a reflection. What does that mean? Well, think of a piece of paper like this. When I fold that paper in half, like this, that crease that's in the middle is like the line of symmetry. Okay? It's like cutting it in half to where when I reflect the two halves of the paper onto them, it's the same on both sides. Obviously there's stuff written over here, okay? But it's the same shape on both sides. So that crease is acting as a line of symmetry. Let's look at some other examples. So a figure in the plane has a line symmetry when the figure can be mapped onto itself by a reflection in a line. So the last thing we want to talk about is the line of symmetry. And a figure in a plane has line symmetry when that figure can be mapped onto itself by reflecting in a line. Okay, so let's look at what I mean by that. So if you look at number 8 here, and the question is how many lines of symmetry does each of these hexagons have? So each of these are 6-sided figures. And so let's look at their lines of symmetry. And so if I were to reflect this figure across this line that runs through the middle, and obviously I didn't get it perfectly in the middle, right? But if I were to reflect it across itself, so like this part reflected over onto this part, it would be on top of itself, right? You wouldn't notice it because it'd be perfectly on top of itself. So this right here is a line of symmetry. And this right here is a line of symmetry because when I cut that figure, and you can imagine like cutting it in half, it would just be on top of itself. And I could do the same thing here. If I go straight down the middle, okay, and I were to reflect this side onto this side, they again would be right on top of each other. Okay? It maps onto itself, is what we say. And so this figure actually has 2 lines of symmetry. Now what about this last one, number 10? Is there any way I can cut this to where it is symmetrical? Well, yes, I can cut it right here, okay? And then this side reflected onto this side would be the same. But I can't cut it any other way, right? If I cut it like that or cut it like that, it doesn't make the same figure. Right? I can only cut it here and it maps onto, and flip it over and then it maps onto itself. Okay, so this one only has 1 line of symmetry. Oops. So let's look at these last few examples real quick. Determine the number of lines of symmetry for each of these. So I could cut it here and then that'd be a line of symmetry. You could do the same thing here. Could go up this way diagonally or down this way as well. So how many lines are there? Those are 4 lines of symmetry. Number 12, I could cut it here And sometimes you're just going to have to look at it and play with it for a little bit. I could cut it there. Or, and sometimes it may even help to like turn your paper a little bit. You can't see me, but I'm turning the iPad so I could look at it. I could do it here. Could here. Here. Or here. I could cut it there. So there's five lines there. Cut each of those to where I'm cutting it directly at a point where if it's reflected on top of itself, it is on top of itself. Okay, last one, number 13. How can I cut this to where if it's reflected, it maps onto itself? And if I cut it here, is that happening? No, because the point's down here, but there's nothing like that down there. It doesn't look the same. Okay, well, what about here? No, definitely not. Same thing. That's a problem. Okay. Well, what about here? Oops. Cut it here. No, that's not going to work either. Even if I go a little bit further down, that's still not going to work. It's not the same, right? This isn't the same as that. So this is an example where it actually has 0 lines of symmetry. So now you have 2 types of transformations in your tool belt, translation and reflection. In the next lesson, we'll look at the third, rotation. But make sure you do some work with reflections before we get to that.